go ahead and look at a couple more examples of reference angles. So again, we're looking at evaluating our trig functions for the given angle. We are going to draw our angle in standard position, find our reference angle, fill in the sides of our right triangle using our two special triangles, and then use our SOHCAHTOA in order to evaluate the trig function. So let's go ahead and look at part E right here. So we're looking at the cotangent of 210 degrees. So first thing we want to do is sketch our angle in standard position. All right, so 210. Okay, remember that, and if we go half the way around, it's 180 degrees, and then all the way around is 360 degrees. So obviously 210 is more than half the way around. It's not quite to 270. It's not 3/4 of the way around yet though. So we're going to be over here in quadrant 3. All right. Okay, so draw in our right triangle to the x-axis. Always draw that triangle to the x-axis. All right, so this was 210 degrees, which means we want to now find our reference angle, which falls between the terminal side of our angle and the x-axis. All right, so in this case, we're trying to think basically how much have we gone past the x-axis, because we went to 180 and then we went a little bit extra to get down here into quadrant 3. So since we know that the x-axis is 180 degrees, we want to find the difference between 210 and 180. So 210 minus 180 leaves us with 30 degrees, which means our reference angle is 30. Okay, so if the terminal side of your angle falls in quadrant 3, you're looking for how much extra have I gone past my x-axis. In this case, how much extra have I gone past that 180 degree mark? Okay. All right. So now let's go ahead and fill in the sides of our triangle. So we have a 30-degree reference angle. So if we use our special right triangle over here on the right, we have opposite a 30-degree angle is 1, hypotenuse is 2, and the adjacent side is root 3. Okay. We're in quadrant 3, where both x and y are negative. And remember, the hypotenuse is always positive. All right, so cotangent we know is the reciprocal of the tangent function. So thinking about our SOHCAHTOA, cotangent is adjacent over opposite. So that's going to be negative root 3 over negative 1. Or of course, that's just going to simplify to square root of 3. So that's going to be our answer. All right, let's go ahead and take a look at another one. So this time we're looking at the sine of 11 pi over 6. Again, we want to start by drawing our angle in standard position. Okay. All right, now again, if you're still not 100% confident with radians, think about your benchmarks. So we have 0, pi over 2 at the top, pi is half the way around, 3 pi over 2 is down at the bottom, 2 pi is all the way around, okay? So if we want to sketch in this 11 pi over 6, we basically just need to think, well, where does 11 over 6 fall in reference to these angles? Okay, well, 11 is bigger than 6, which means we've gone past pi, but 11 isn't double 6, which means we haven't gotten to 2 pi yet, so we're down here somewhere on the bottom half, either in quadrant 3 or quadrant 4. So we just have to think, okay, well, is 11 over 6 less than 1.5 or more than 1.5? And it is, of course, more than 1.5. So we're going to be over here in quadrant 4. Oops. All right, so once again, draw your right triangle to the x-axis. Let's get rid of these. Okay, so this was 11 pi over 6. Okay, all right, so now we need to find our reference angle. Now again, like I had here a second ago, we know that going all the way around is 2 pi. So we just need to figure out how much more do we need to go in order to get to 2 pi. Well, again, fractions always think common denominator. So if we think common denominator, 2 pi, if we're using this denominator of 6, is equivalent to 12 pi over 6. So we've gone 11 over 6, we have to get to 12 over 6, so we just need 1 pi over 6 more to get there. So that is going to be our reference angle. Okay, so now just fill in our sides. So our reference angle is pi over 6, so using that special triangle on the bottom on the right-hand side. Our opposite side is 1, hypotenuse is 2, and our adjacent is root 3. We're in quadrant 4, so x is positive, but y is negative. And we're trying to evaluate our sine function. So sine we know is opposite over hypotenuse, so that's going to be negative 1 over 2. That's going to be our answer. All right, let's go ahead and take a look at another one. Okay, so this time we want to find the secant of 8 pi over 3. Okay, so again, we're going to need to sketch our angle in standard position. So hopefully you guys recognize, looking at 8 pi over 3, that this is more than a full rotation around the circle. Okay, and the easy way to see that is just that 8 is more than twice as much as 3, and we know that 2 pi is all the way around, so it's gone more than a full rotation around our circle. So we just need to find that coterminal angle again that is less than 2 pi in order to help us figure out where to plot this. So over here on this side, I'm just going to do a little scratch work. So I'm thinking 8 pi over 3. I want to subtract a full rotation, so I'm subtracting 2 pi. Find a common denominator whenever you're working with fractions. Okay, so if we find that common denominator, 2 pi would be 6 pi over 3. So 8 pi over 3 minus 6 pi over 3 would leave us 2 pi over 3. All right, so these guys, 8 pi over 3 and 2 pi over 3, those are coterminal angles, meaning they have the same terminal side when you graph them. All right, so 2 pi over 3, all right, 2/3 is more than a half, but it's less than 1, which means we're going to be in quadrant 2. All right. So that's our 8 pi over 3 there. So we went all the way around plus 2 pi over 3 to get us here. And then just draw that right triangle down to your x-axis. Okay, so next we need to find our reference angle. Okay, so right now we've gone 2 pi over 3 if we just think of that coterminal angle. So we've gone 2 pi over 3. We need to think about how much more do we need to go in order to get to the x-axis. Well, the x-axis right here is pi, or that would be equivalent to 3 pi over 3. So 2/3 plus 1/3 would get us to 3 over 3, or 1. So this guy right here, our reference angle is pi over 3. Okay. All right, using that special right triangle again, with pi over 3 as our reference angle. Oops, I just dropped my pencil. Pi over 3 as our reference angle. Our adjacent side is 1, our hypotenuse is 2, and our opposite side is root 3. We're in quadrant 2, so x is negative and y is positive. Okay. Secant is the reciprocal of cosine. So secant is hypotenuse over adjacent. So this is 2 over -1 or -2. Okay, so that is our answer. All right, guys, so I'm going to leave the rest of these examples for you to try on your own and practice with. The solutions to the rest of these are going to be posted up on Blackboard, so what I would recommend is try them out and then go ahead and double check your answers with what's up there. And if you have any questions on anything, you are more than welcome to send me an email and I would be happy to help walk you through any of these. Okay, so keep practicing and then move on to the next section, which is going to be the unit